Okay, 3.1 is measures of central tendency, and you're familiar with measures of central tendency. You might not be familiar with this phrase, but here's what it refers to. The four main ideas that we're going to be talking about in 3.1, and honestly, in chapters 1 and 2, it's been more statistical based and vocab based and concept based and less sort of math based, what you guys would think of mathy. That's going to change now. We're going to start really working with numbers and doing calculations and more of that, and so it's going to start to feel more like a regular math class now. And we're going to look at some symbolism and mathematical symbolism that's going to possibly be new to you, but I'm going to explain it all, and I just want you to become familiar with some of it because you'll see it in the book as well as in our notes, okay? So I'm just going to go through these four things quickly, and then we'll work on some problems, and then I'll show you another example that's a little bit different from what we're used to, okay? So the mean is the average of the data, okay? And you guys know how to find the average. You've worked with mean before. You probably did it in middle school, honestly. How do you find the average?
You can add up all the numbers and divide by how many numbers there are.
Very good. Add up all the numbers, divide by the number of numbers. And another way to do that is this way. The sum of all the data values, so that's add up all the numbers, divided by the number of values that there are, okay? Just to make sure we're all on the same page. We are actually going to look at two different means, and the symbolism is going to be a little bit different. The process is basically the same, but you're going to see some symbols that might not be familiar to you. Go ahead and write them down, and then I will do my best to explain what they all mean, okay? So here's the first one. Well, before we get there, there's two different kinds of means you may be asked to find. One is a sample population, sample mean, and the other is the population mean. So the mean calculation can be done for a sample, so a portion of the population, or for the entire population. And the symbolism is a little different. The calculation is a little different typically, but for our purposes it's going to be essentially the same. But I want you to see how the symbolism is different from one to the other, okay? And you may remember when we did some of our calculations on our scatter plots that you saw this X with the bar over it. That means the mean, okay, for the sample. This is a capital sigma, Greek letter sigma, okay, and it represents the summation. It means add up all the x's. So when you see this symbol, that's a capital sigma, Greek letter sigma, and it means the summation of all the x's. Add up all the x's. And those of you guys who did pre-calc before probably have seen this, but if you haven't done pre-calc, you probably haven't seen it.
Is that x and exponent or no?
No, it's a little off. It's just this. Let's see if I can draw it so you can kind of see what it actually should look like. It should look like that. Boy, that's a terrible signal, but you get the point. Okay. And then n is the number of values in the sample. Lowercase n, the number of values in the sample. X bar is the sample mean. Sigma x, the sum of all the x values, or the data values. And n, the number of values in the sample. For the population mean, it's essentially the same, but there's going to be two different symbols that you haven't seen before. Okay, this is a Greek letter, lowercase mu, mu. Okay, so for those of you who might be in mu alpha theta, that's that, mu. Again, sigma x, the sum of all the x's, and now the number that you divide by is a capital N, and that n represents the total number of values in the population. That's the distinction between the uppercase and the lowercase n. The uppercase represents the number of values in the population. The lowercase n represents the number of values in the sample. Okay. These are both means, one sample, one population. And make sure when you write this you don't just draw a U. It does have this little sort of long piece in the front. The good thing for you is most of the time the mechanics for finding the sample mean or the population mean are the same. The symbolism will be a little different, but you do the same thing for each one, depending on whether it's a sample or a population, and they will tell you. Most of the time, they will tell you whether you're dealing with a sample or population, okay? Any questions about that? All right, the next thing we need to look at is the median. Okay. And the median is the middle value when they're in order from smallest to biggest. So most of the time, your data won't be in order. So the first thing you're going to want to do is put it in order from smallest to biggest and then find the middle value. Now this works well when there's an odd number of data values because the middle value will actually be one of the existing data values. When there's an even number of data values, it works a little bit different. Okay. The average, you take the average of the two middle values. So if there's an even number of numbers, then you take those two middle ones that are in the middle and you average them if they aren't the same. Sometimes those two numbers will be exactly the same, and so the average of that is that number. But more often than not, those two numbers will be different, so you have to take the mean of those two middle numbers to find the median. So it is possible that the median of a set of data is not actually one of the numbers in the set of data. So yeah, I'll say that again. So if there's two numbers in the middle, because you have an even set of data that are the same numbers, so for example, if those two middle numbers are 10, the average of 10 and 10 will just be 10, right? 10 plus 10 is 20, divided by 2 is still 10, right? So most of the time that's not going to happen, but it will happen sometimes. And then it's fairly easy, okay? Let's talk about the mode. That's the data value that appears the most times. And there's some different terminology that than what you've seen in the past that we're going to use that I want you to become familiar with. Sometimes there will only be one mode. There will be only one data value that appears the most times. And if that happens, then it's called unimodal. So that means there's only one mode, unimodal. Anybody want to take a guess at the phrase for if there's two data values that appear the most? Bimodal. You're so smart. Good job. Two data values appear the most, then it is bimodal. Then instead of talking about three data values, four data values that appear the most, what we say is if there's more than two that appear the most, we call that multimodal. Okay. So we designate three different characterizations of the number of modes that there are. If there's one mode, unimodal. Two modes, bimodal. More than two modes, multimodal. There is one other case that we need to look at. Sometimes all the data only appears once, meaning there isn't one that appears more than another. And in that case, that it has no mode. So if all the data values only appear one time, then we say there is no mode. So the mid-range, you guys know what the range is? Oh, I already told you. Dang it, it's already up there. So the range is the highest value minus the lowest value. All right, the mid-range is the average of the highest and lowest value. So you're going to add those two things together, divide by 2. All of these values, the reason they're called measures of central tendency is because they give us indication about what's going on in the middle of the data, centrally. All right, mid-range is one way to look at the middle of the data. Mode is one way to look at the one that occurs the most, and it might be the middle of the data. Median is literally the middle of the data, and the mean is the average of the data. So these are things that we can use to help make conclusions about what's happening with the data, and ultimately that's what statistics are all about. Taking data, drawing conclusions, using it as evidence to support a theory that we might have, okay? And so now we're going to get into some statistical analysis to try to see if we can figure out what's going on with the data, okay? So mid-range, lowest value plus the highest value divided by 2. Now we're gonna do an example where you have to find all of these things. And so what I want you to do is take a picture of this screen. Okay, and then work through A, B, C, and D on your own, and then we'll come back together and see what you came up with. The mean, what is, when you add up all the data, what do you get?
15.1.
No, you get like,
When you add up all the data,
136.
136, and then how many data values are there?
9.
9, okay, so this is your setup, 136 divided by 9, so my mean is
15.1.
50.1. How many had that? Very good. The median, we gotta put it in order first. Now, one of the things that I like to show you, just to give you, reminisce about the old days when you were a little kid. Maybe some of you found the median like this. You crossed off the end and you started moving your way in. How many did it like that? Back when you were little. How many did it like that today? How many did it like that today? Cool. Reminiscing, it's good. Good to do. So you keep crossing off and then 7 is in the middle. Now, let's pretend for a minute, just real quick, that there was another data value and these two were in the middle because it was even. There, I'll just add another value. That's probably in the wrong place now too. Let's see. 4, I'd have to put it over here. Let's make it 63. Let's pretend that was there and these were the two middle ones instead because I had an even number of data. I'd just take the average of that, which would give me 9. Okay, obviously that's not the case, but I wanted you to see that should you be in that situation. The mean is, of course, 7. Okay, is there one value that appears more than any other?
Yes.
Okay, what number is that?
3.
3. And we would describe that mode as what type of mode?
Bimodal.
No, it's
Unimodal.
It's unimodal. There is only one mode. Even though it appears twice, there's only one of them that appears more than once. Okay, so 3, there's only one mode right here, right? So if there was more than one mode, that's where we would go. If there were 2 modes, then we'd call it bimodal. There's only one mode, so this is unimodal. And the mid-range, 1 plus 61 divided by 2, that is just 31. Okay? This stuff you've done before. The stuff that I'm about to show you is going to be new. Okay? And how we approach this is really important because you're going to need to know how to do this. So on this page, I want you to take a picture. I want you to take a picture of this page because sometimes you'll be asked to find the mean from a set of grouped data, and I want to make a distinction as to why this is so much different. So we can still find the mean from a set of grouped data, and the thing is the reality is we don't actually know what the data is. We know that there's one data value in this class, but to know specifically what the data is that's in there, we have no idea. It could be 6, could be 9, could be 10, right? We don't even know. And so with group data, when you're presented with group data, you don't know the actual data. So what we do instead is we pretend that we know what the data is. And we approach it like we know what the data is. And the way that we do that is we come up with the midpoints. We use the midpoints as if that was the data, okay? So what I want you to do right now is finish that column. Find the midpoints of all of these. Eventually you'll find a pattern, and so you'll only have to do it for a couple of them. And then I'll talk about how we use that to find the mean. The midpoint, right, I add these two together, divide by 2, so this is 16 divided by 2, that's 8. Okay, and then here I add these together, that's 26, so divide those by 2. Right, that's what your midpoint should be. So take a look at your screen. Once you get the first couple, you should see that there's a pattern. Okay. So here's why the midpoints are important. Since we don't actually know the data, what we're going to do is pretend that the data are the midpoints. So we're going to pretend that there's 1 8 in the data set. We're going to pretend that there's 2 13s. We're going to pretend that there's 3 18s and so on. That the midpoints actually represent the data. So when I add up all the data, the quote-unquote data, to find the sum of all the data in order to help me find the mean, what we're going to do is use the midpoints. All right? And so this last column is the frequency times the midpoint. That's what this symbolism means. Because what we're saying is 8 times 1, because there's one value of 8. 2 times 13, because there's 2 13s. 3 times 18, because we're going to say there's 3 18s. And then we're going to add all those up, and that will be our sum of the data. And then we divide that by the number of numbers, and that's our mean. Okay? So go ahead and fill that column out. Frequency times the midpoint. Because then we're going to add that column up. And then actually add that column up. Find this column and then add them up too. Because we're going to take the sum of basically all the data. So again, what we're doing, why we multiply these is, if I have 2 13s, for example, I could add 13 plus 13, but the shortcut, that's what multiplication is. Multiplication is a shortcut for addition, right? I could add up 23 5 times, but the faster way to do that is to multiply it by 5. So here's that last column. And what this means again, and again this sigma, this means the sum of the frequency times the midpoint. So this is like I had 1 8, 2 13s, 3 18s, 5 23s, 4 28s, 3 33s, and 2 38s in my data set, and I added them all up, right? This is just sort of a slicker, quicker way to do that. So the sum of all the data, quote unquote data, because we don't actually know the data. We're pretending that the data is represented by the midpoints. So to find the mean, I take this sum, divide it by the number of numbers, and that gives me my mean. And that's what this symbolism means, okay? And again, the reason I'm showing you all this is it appears in the book. So if you're looking in the book at all, I want you to become familiar with this. So again, this is the sample mean. The sum of the frequency times the midpoint divided by the number of numbers. All this is 490 divided by 20. And for this particular problem, that mean is going to equal 24.5. This example, I guess, happened to be about distances or miles or something. Probably could just leave that off for this example, since I didn't provide the context for you anyway. Okay. So again, conceptually what we're doing with group data is we're pretending that the midpoint is the actual data value, and we're just adding all the quote-unquote data values up, dividing by the number of numbers. So same idea, the only difference is with group data, we don't know what the actual data is. Okay? Couple more things to go through. Since we don't actually know the data, we can't technically find the mode. But what we can do is find what's called the modal class. Okay? So we're looking for the class that appears the most, if there is one. So this data is the same data as what we had on the previous screen. Okay? Same data. Which class appears the most? Has the highest frequency? 20 to 25. So our modal class is 20.5 to 25.5. So instead of designating one particular data value as the mode, for group data what we say is there's a particular class that is the modal class. It is possible, in this case it's unimodal, it's possible to have more than one modal class as well. Okay? The same concept of having to appear more than once to be the mode applies to modal class. Last thing we need to cover is weighted mean. Okay? And the weighted mean is, the example I'm going to use has to do with how, for example, in my class, I do grades. Right? There's 3 different categories. They each have a different weight. Homework's 15%, quizzes are 25%, tests are 60%. So sometimes each category doesn't have the same value. You guys have learned how to calculate your semester grades with quarter 1 grade, quarter 2 grade, and then your semester final, and you've weighted it that way too. So same kind of idea. All right. So let me give you an example. Sometimes the data values in a set are not weighted equally. Okay. Then the means are considered the weighted means. And the example that I'm going to give you has to do with, theoretically, somebody's grade. And we'll go through how to calculate your grade if this was you. The example, like I said, in my class is going to look like this. All right, let's pretend that there's a student, who knows, maybe this is you, that their homework grade is 95%, their quiz grade is 87%, their test grade is 89%, and then there are the weights that my class uses. Okay. So instead of just adding these numbers up and dividing by 3, we can't do that because they don't have equal weight. So what we do is we take the particular grade for that category and multiply it by the weight. Then add those up and divide it by the total percent. Okay? And in this case, it's 100%. In the beginning of the year, for example, after your first quiz, we don't have this test grade section. So in that case, we'd only divide by 40% before we have our first test. That happened earlier in the year and will happen early every quarter. All right? So go ahead and do that. Multiply the grade by the weight, and that will give you the weighted mean, or the person's grade. I show you my example, I'm gonna turn them all into decimals. You can turn one of them into decimals, and then for example, if you turn the weights into decimals and leave the percents as whole numbers, then your answer will be given to you in a whole number representing percent. And then it saves you from doing a conversion, but you know, you guys know how to convert from decimals to percent. So here's what my work looks like. Okay. So I took 0.95 times 0.15, 0.87 times 0.25, 0.89 times 0.6. Again, if I would have left these as whole numbers, my final answer would be as a whole number. But I divide by the sum of the weight. Okay, in this case it's 100%, which is 1, so essentially I'm just dividing by 1, which means adding this up will be my answer. But sometimes the weight won't be a percent, so you'll have to add this up and divide by that number. All right. In this case, this person's grade is an 89.4%. So what I would have gotten here is 0.894, okay, and I just converted it back to a percent. Alright, so this is how you find a weighted mean. This is an example of a weighted mean. Okay, when you get to your problems in your homework that have weighted mean, you're still going to do the multiplying, then you have to divide by the sum of whatever the weights are. Okay. Are there any questions about any of it?